Hi, today I'm going to be taking red cabbage leaves into distilled water to create a natural pH indicator and testing that on different things of different pHs. The materials that I'm going to be using is red cabbage leaves and distilled water, 2 cups for every 1 leaf. And the materials I'm going to be testing on is vinegar, lime juice, baking soda, soap, I'm using Tide, and tap water. My independent variable is the different substances I'm going to be testing in the pH indicator, and the dependent variable is the color that the pH indicator turns, and that is an indicator of the substance's pH. The first thing I'm going to do is blend together hot distilled water and cabbage leaves, and I'm going to be adding 4 cups of hot distilled water and a corresponding amount of red cabbage leaves. It should be about half the amount of water. Step would be to strain out all the big pieces of cabbage with coffee filters and a funnel. This is what the pH indicator cabbage water looks like. Now the mixture of the pH indicator / red cabbage water will be poured into 5 glasses equally. The first thing I'm going to be pouring in is vinegar, which has an average pH of 2.2. As you can see, the color brightens up quite a bit, indicating that this is an acid. Now I'm going to be adding the lemon to the pH indicator. As you can see, the color changed much more into like a vibrant pink red, indicating that it could have a higher acidity than vinegar. And fact checking that, lemon juice has an acidity of about 2. Next, I'm going to be testing tap water on the pH indicator. As you can see, there's very little color change, meaning that tap water is a relatively neutral substance. And to fact check that, tap water has an average pH of about 7, making it right in the middle of the acid-base scale, making it neutral. Next, I'm going to be testing baking soda on the pH indicator. As you can see by the color change, it's a very vibrant, lighter blue color, and that indicates that this substance is a basic substance. Fact checking that, baking soda has an average pH of about 8, making it, in fact, more on the basic side. Lastly, I'm going to be testing some sort of soap product on the pH indicator, and I'm using Tide laundry soap. As you can see, the color change is a very vibrant, dark, like violet blue color. And that is an indicator that this is a very strong base. And to fact check that, the Tide soap I'm using has an average pH of about 10.5, in fact making it quite basic. This is a good picture showing all the side-by-side comparisons of all the different pHs of the things we tested, including the control or nothing tested on the measuring glass on the right. This picture is a good key to show how the substances I tested coincides on the pH scale given. So a question we can derive from the experiment is what defines an acid and a base? What makes a substance acidic in the pH indicator and what makes it basic, despite having the same concentration of everything in the pH indicator? And this comes down to the formation of H3O plus in water or OH minus, H3O plus being hydronium ions and OH minus being hydroxide ions. Arrhenius' principle found that all acids form H3O plus in water and all bases form OH in water. Additionally, not all acids and bases form these substances as regularly or as easily. So what defines a strong and a weak acid is also based on H3O plus. If an acid is defined as strong if it easily forms H3O+, meaning it is more likely to give up protons. It's a weak acid if it only partially forms H3O+. Same thing for bases. A strong base easily forms OH-, whereas weak bases partially form OH-. This can be further explained by the Bronsted-Lowry definition, which is an expansion of Arrhenius's. And this says that acids donate protons, which is why you see H plus going and the hydrogen ion formation, and bases accept protons, which is why you see the OH minus charge, because it accepts protons. This all relates back to what pH even is, as pH is simply a scale that measures the concentration of H3O plus ions. So why is this useful to real life? Well, it's used for many things. A pH indicator is used for smaller scale things like biomes. If there is an acid or base scale, indicator is often put into the biome affected. If it shows up as an acid that's been spilled, base is then added until the pH indicator shows that it's been neutralized. It's the same vice versa. If a base is spilled, the certain amount of acid will be added to neutralize the base that has been spilled into the biome so that no harm can come to the ecosystem. On a bigger scale, however, we see things like ocean acidification. pH indicators show how acidic the ocean has become, because as carbon dioxide enters the ocean, it forms carbonic acid and bicarbonates eventually, which raises ocean acidity and lowers pH. So you can use a pH indicator to show CO2 levels in the ocean. As CO2 levels rise, the pH indicator will show that the pH will lower because the acidity is going up.